Vectors are an essential and ubiquitous part of game development, and in this video I will teach you everything you need to know about vectors in just under 4 minutes. So let's dive into some thoughts of code. A vector in game dev can either be a transform value like the position or the scale of something, or it can be a direction. Let's imagine a 2D grid where you want to get from coordinate 1, 1 to coordinate 3, 4. The distance of the shortest path can be described in a vector. When the base of the vector looks like this, the vector which gets me to point B would look like this. A more complex path would have to be calculated like this by subtracting one positional vector from the other. Now, this concept also works in 3D. And just like subtraction of two vectors, you can also add them, multiply them, or divide them. To calculate the magnitude or length of a vector in 2D, you can simply use the Pythagorean theorem. Take the x endpoint of the vector, which is 3, and subtract the x start point. That will give you the x length of the vector. Then you do the same for the y length of the vector. Square and add these two, and this will leave you with the length of the vector squared. Since we just want the length, we'll add a square root. When you want to do this in 3D, you can just add the z length of the vector under the square root. Let's look at the following scenario. You have a triangle that should always move toward the mouse. Let's store the pixel position of the mouse in a vector 2 and convert it to world position with this. To get the direction from the triangle to the mouse, we'll subtract the current position of the triangle from the mouse position. This direction is a vector that stores the whole path to the mouse. But since we only wanted to show the direction, we'll normalize it. A normalized vector has a magnitude of 1 and thus can also be called a unit vector. Let's quickly go back to our initial example with a vector from 1, 1 to 3, 4. We calculated that the magnitude of this vector was the square root of 13. To normalize it, we'll divide each of its components, 2 and 3, by the square root of 13, its magnitude. So the normalized vector looks like this. And now we can just set the rigid body's velocity, which will be initialized in the start function, equal to the direction vector. You can control the speed of the triangle by just multiplying with a speed variable. But since I want the triangle to slow down when it comes near the mouse, we'll also initialize a max speed variable and a slowdown radius. To determine how far we are away from the mouse, we can use the magnitude of the vector and store this in a variable called distance. Now we just need one more variable, the speed modifier, which will be equal to an inline if statement, so that if the distance to the mouse is smaller than the slowdown radius, the speed modifier will be equal to the distance divided by the slowdown radius. Else, the speed modifier will just be 1. Now we can set the speed to the max speed times the speed modifier. Second to last, you should add this if statement so that the triangle doesn't start jittering when it's at the location of the mouse. And lastly, you can add these two lines to make the triangle face the mouse. Now you have a good understanding of what vectors are and how you can work with them. You should start developing something yourself with them to deepen your understanding. Good luck creating.